Now that we know that permutations order matters, and again, remember, a permutation basically just tells us how many different ways can we order a certain number of things. And in permutations, unlike combinations, order matters. So 1, 2, 3, 4 is different than 4, 3, 2, 1, just like on your phone if you're trying to enter a PIN. There are two different types of permutations. We're going to talk about both of them in separate videos. But first, there's where repetition is allowed. So this is like on your phone. You can put in your code as 0000, right? Or you could put your code as 1122. That would be totally fine, right? Repetition is absolutely allowed in some permutations. And so that's the type we're going to talk about in this video. And in the next video, we'll talk about permutations where repetition is not allowed and how we calculate them. So first of all, permutations with repetition are super easy. They are definitely the easiest of all to calculate. So let's say that you're going to make a PIN for your phone. And you can have a 4-digit PIN. So how many different ways could you make that 4-digit PIN? So let's imagine that you were going to draw a tree diagram. Now, we are not going to draw a tree diagram for this entire thing because it would just get out of control. But let's just imagine. Okay, so here you are. Should we put your little cell phone in your hand? There you go. Beep, 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 beep. Okay, that's a cell phone. All right, you got your cell phone in your hand and you're trying to figure out this PIN, right? So the first option you have for the PIN is one of 10 numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You could do 0, you could do 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? Those are all the different numbers that you could pick for the very first number of your PIN. Okay, so you have 10 options for the first number. What about for the second number? Okay, well, you could do 0, 0. You could do 0, 1. You could do 0, 2. You see how this is going to get out of hand really quickly? Because imagine this is going to have 10. That's going to have 10. And this is going to have 10. And this is going to have 10. And this is going to have 10, right? And this is going to have 10 options because I could do 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. I could do any of those, right? I could do 1, 1, 1, 0, 1, 2. I could do all of those. So the first digit, I have 10 options. The second digit, I also have 10 options, right? So how many options do I have if I just pick 2 numbers? Well, I have 10, and I have 10 for each of those options, so that's 10 times 10. So I now have 100 options, 100 different ways that I could do a 2-digit PIN, right? Okay, so there are 100 different options for a 2-digit PIN. What if I want a 3rd digit? Okay, so off of this 0, I could now have 10 options. And off of this 1, I could have 10 options. And do you see how this, there's no way that you could draw this without being a crazy person. So don't try. So we have another 10 options if I have a 3-digit PIN, right? Because I have 10 times 10 times 10. Okay, so now I have 1,000 options for what my PIN could be. It could be 0, 0, 0. It could be 0, 0, 1, 0, 0, 2, 0, 0, 3. Do you see how I could have listed all of those and my sample space would have 1,000 options? Okay. Finally, what if we want a 4th number on here? Oh, that would be the 3rd number. Okay, so now we want a 4th number on here. And imagine, again, there's like 10 options off of each of these numbers, okay? So we're just going to multiply this by 10 one more time because for every level, we have 10 times 10 times 10 times 10. So how many different options do we have for a 4-digit PIN where I could repeat the numbers each time? Well, we would have 10,000, right? So there are 10,000 different ways that you could make a phone PIN with a 4-digit phone PIN. This is called the fundamental counting principle. It's one of the most basic permutations that you can calculate. Basically, if you have, if you're trying to figure out how many different options you have of something and you can repeat and order matters, all we do is just multiply those numbers together and it gives us the number. Okay, so this is how we would write that with actual notation. So if we have n different types of n different things, okay, so in this case we were talking about a phone pin, and there are 10 different choices every time, right? So if I have 10 choices every single time, and I can repeat that, then all I do is multiply 10 times 10 times 10. And in our case, we multiplied it 4 times because we were picking 4 numbers, okay? So n is the number of choices we have, and r is the number that we're picking, okay? And this is true for all permutations and combinations. N means how many different choices we get, and R means how many times are we making a choice, right? So in our example of runners in a race, N would be 16 and R would be 3. Now this one would not work for this because we can't repeat a runner. So this one would not be a permutation with repetition, but if you just think about what n is, what r is. Okay, n again is the number of choices we have. R is how many times we actually pick one. So in our example of the phone pin, we have 10,000 different options. And so our formula is actually very simple. N to the r. We just take however many choices we have, we multiply it by itself, r times, which is how many options we have. Another example of this would be, say you've got a deck of cards and you're going to pick 3 cards, but you're going to replace it every time. You're going to pick a card, look at it, put it back. Pick a card, look at it, put it back. Shuffle, of course, so that you just, you know that you could be picking different cards. Anyway, pick a card, look at it, put it back. Okay, so you're going to pick 3 cards out of this deck of cards. How many different ways could you pick 3 cards, right? Could you pick the Queen of Hearts, Queen of Spades, Queen of Hearts? You could pick Ace of Spades, one is not a card. You can tell I play a lot of poker. 2 of hearts, something like that. Okay, so there's lots of different groups, and I hate to say the word combinations, but there's lots of different combinations of ways you could pick those cards, right? So how many different options would we have? Say you're going to pick, you have a deck of cards, you're going to pick 3 cards out of it, and each time you pick a card, you're going to put it back, which means we can repeat cards, right? So the first time you pick a card, how many different cards are possible that you could pick from? 52, right? Okay, so you have 52 choices that you could pick. Then, how many times the second time you pick a card, how many choices do you have? You also have 52 again because you just put the card back, right? And then the third time you pick, you also have 52. So we would have 52 times 52 times 52. And if we wanted to put that into our formula, we could think about, okay, so n is how many choices we have each time, and we had 52 choices each time, right? And then r is how many times we pick. Well, we picked 3 times. So 52 to the third would be how many different ways we could pick 3 cards from a deck if we pick them one at a time and put them back.